Hello, everyone. We'll dive into the concept of central tendency, a fundamental idea in statistics. Central tendency refers to a single value that represents the center of a dataset. It helps us summarize data, and we typically describe it using three measures: mean, median, and mode. There's also a variation called the weighted mean, which we'll discuss later. We'll explore how to calculate these measures and understand when to use each one. Let's get started. Population versus sample. Before we calculate mean, median, or mode, it's important to differentiate between population and sample. Population refers to all individuals in a group, such as all people in a country or students in a school. Sample is a smaller subset of the population, like a city's residents or students in the front row of a classroom. Think of population as a big circle and sample as a smaller circle within it. In statistics, we often use samples to estimate population characteristics. The mean or average. The mean is the most common measure of central tendency. It is calculated by adding up all the values in the dataset, dividing the total by the number of observations. Sample mean formula. For a sample, the formula is x bar equal the sum of xi divided by n. For example, if we have a dataset with 5 sequence values, 6.2, 7.1, 4.8, 9.0, and 3.3, the calculation would look like this: 6.2 plus 7.1 plus 4.8 plus 9.0 plus 3.3 divided by 5 equals 30.4, divided by 5 equals 6.08. So the sample mean is 6.08. Population mean formula. The formula for population mean is similar, but uses a slightly different notation. Mu equals the sum of x's divided by n. Here, n represents the total number of observations in the population. Weighted mean. The weighted mean assigns different levels of importance, weights, to values in the dataset. The formula is x bar equals the sum of wi times xi, all divided by the sum of wi. Let's look at an example. A student's final grade is based on three components: assignments, 80% weight; midterm exam, 10% weight; final exam, 10% weight. Let's calculate the weighted mean step by step. First, we need to convert the weights into decimals, which are 0.8, 0.1, and 0.1. Next, we multiply each grade by its corresponding weight. So, for assignments, we take 75 and multiply it by 0.8, which gives us 60. For the midterm, we multiply 70 by 0.1, which equals 7. And for the final, we multiply 85 by 0.1, which gives us 8.5. Now we add all these values. That gives us a final score of 75.5 after being divided by 1. So the weighted mean for these grades is 75.5%. Advantages and disadvantages of the mean: simple to calculate and understand, summarizes data with a single value. Disadvantages: sensitive to outliers. Outliers are those values that are way higher or lower than most of the data. Imagine asking a group of people how much money they have in their wallets. Most people might say $10 or $100. But then someone in the group says, I have $1 million. That one extreme value, the outlier, would pull the mean way up, making it seem like everyone in the group has more money than they actually do. This is why the mean can sometimes be misleading. When outliers are involved, it doesn't always represent the typical value in a dataset. Now let's take another example. Imagine we're asking a family how many pets they have. Most answers might be something like 2, 3, 4, 5, or 6 pets. If we add these numbers and divide by the total number of families, we might find the mean is 4. But now, let's say One family says they have 100 pets. That doesn't seem realistic, right? This extreme value, the outlier, completely changes the mean. Instead of 4, the mean might jump up to 22.8, even though most families only have a few pets. The median. The median is the middle value in a data set, with half of the observations above and half below. To calculate it, arrange the data in ascending order. Use the formula n divided by 2 to find the position of the median. Odd number of observations. For example, in a data set with 7 values, first we arrange them from smallest to largest. Take the total number of values, which is 7, and divide by 2, which gives 3.5. So we can round up to 4, which gives the first numbers in our list, the middle ones, so the median is 28. Even number of observations. Let's find the median of these 6 numbers. First, we arrange them from smallest to largest. Step 2. Find the middle. Take the total number of values, which is 6, and divide by 2. That gives us 3, meaning the third and the fourth numbers in our list are the middle ones. Looking at our list, the third number is 170, and the fourth number is 182. To get the median, we add them up and divide by 2. So the median is 176. Advantages of the median, not affected by outliers, ideal for skewed data. The mode. The mode is the most frequently occurring value in a dataset. It's especially useful for categorical data. For example, in a sample of households with the number of pets. The mode is 2 because it occurs most often. Advantages and disadvantages. Advantages, useful for categorical data. Disadvantages, a dataset may have no mode or multiple modes. Choosing the right measure mean is commonly used for numerical data but is sensitive to outliers. A median is better for skewed data or when outliers are present. Mode is the best choice for categorical data. Let's talk about distribution shapes and how they affect the relationship between the mean and median. Symmetric distribution. If a distribution is symmetric, it means the data is evenly spread around the center. This results in a bell-shaped curve where the mean and median are equal. You can think of it as a perfectly balanced dataset. Skewed distributions. Now, when the data is not balanced, we call it skewed. There are 2 types, left skewed or negative skew. In a left skewed distribution, the tail is longer on the left side. Here, the mean is smaller than the median because extreme low values pull it down. Right skewed or positive skew. In a right skewed distribution, the tail is longer on the right side. In this case, the mean is larger than the median because high values pull it up. Quick recap, symmetric, mean equals median left skewed, mean less than median right skewed, median less than mean. Thank you for joining this session on central tendency. I hope this helps you understand how to calculate and interpret the mean, median, and mode. Happy learning!